Okay, hello, and I hope you're doing well. I guess today you guys had Arabic. So today what we're doing in science is just a continuation of yesterday for aerodynamic design, and I have lots of videos to show you guys today to help get your creative juices flowing a little bit more for the design, what you are going to be coming up with, to show like something that is aerodynamic compared to something that's not aerodynamic. Okay, so here we go. This was what you were kind of tasked with yesterday, was to think about a design of your own experiment to prove the idea how the number of block surfaces on an object impacts the drag that it has, and how, I guess, conversely, aerodynamic it would or would not be. So this is the question. Does the change of surface area create more or less drag? So I think that what do you think about the surface area? If we increase the surface area, would that create more drag or less drag? If we decrease the surface area, would that create more drag or less drag? And then what is like an actual like real life example that you could make to show that? So that's what you're thinking about. And I know that maybe you're kind of just like still really not really sure. So I have some videos to give you some examples of, this kind of this idea in action. Okay, so here we go. All right. Okay, so here, let's watch this one first. Okay, now this kid's not speaking English, but check this out. Okay, different shapes, and he's testing the aerodynamics.
Ja.
Okay. It's not English. I think what he's saying is like testing the aerodynamic forms. There's weights on the end, and they're pulling these things forward. And then which one, okay, so which one had the fastest ability to move? Let's just see. Okay. So if we were to do a prediction, probably this would be the worst one maybe, because look at the number of block surfaces. But then between these two, right? This one, the teardrop compared to this one, interesting. And look at these ones. They're almost tied. Okay, cool. So that is... Okay, cool. So that was... Okay, there's so many cool things we could watch about this. I'm going to post some of them for you guys to see on Edmodo. Why does it do this a little bit later? Okay, so I have one more video to show, which is kind of cool. Okay, so this is... You could think about something like this with a design idea as well. This is cool.
This place is pretty cool. It's a reduced scale wind tunnel. My name's Nina Tricosa, and I'm the senior engineer here at the General Motors reduced scale wind tunnel, and I'm in charge of the wind tunnel and the rolling road systems. The advantage to scaling down models for testing is that it makes the whole development process so much more efficient, because we are sculpting smaller pieces and it goes a lot faster. The 40% models that we have here have full suspension and a very detailed underbody. And this wind tunnel also has a rolling road system, which means that the road moves underneath the vehicle. It allows the wheels to spin. And why that's important is because now we can match the road to the wind speed. It helps better simulate the flow that's going underneath the vehicle. It's a better representation of what's actually going on.
Cool.
The reduced scale models, even though they have a much more detailed underbody, will still have the clay exterior, and so we will still be able to do a lot of the on-the-spot clay changes that we did. That's why the wind tunnel is still such a valuable tool for us, because you can get a lot more throughput in the wind tunnel. I can make 15 changes in one shift and get 15 data points. The majority of our development is in reduced scale. And so one of the driving factors in building this facility is that efficiency. By building a reduced scale wind tunnel, we can now run a smaller fan because we have a smaller test section. because we're running a smaller size model. What we've been focusing on is how do we increase the aerodynamic efficiency of our entire fleet, everything from the small cars to the big trucks. This facility will increase our capacity significantly to develop the aerodynamics of our future products.
Cool. Okay, so neat. Okay, now, whoops. Okay, now there is one more video, but this one's actually, whoopsies. Okay, this one's actually a little bit long, and it just kind of goes over the same points again, but he shows like, it's long, it's like 10 minutes or so. If we were in class, we'd watch the whole thing, but I'm just gonna post it so that if you guys want to watch it, you can. And it just talks a little bit more about like spoilers and different designs of cars. So yeah, probably will give you a few more ideas. Now, okay, now this is going to be your task. And some people have already started sending me stuff, but maybe you have other ideas now, or if you want to do a little bit more searching online, you can too. So this is what I'm gonna post on to Seesaw right away. Okay. So the lab is aerodynamics. Design your own experiment to prove how aerodynamics can be shown. The scientific idea is, yeah, okay, actually kind of like that before there. Okay, so the scientific idea is how the change in surface area will affect the amount of drag. So that's our main kind of like thinking question or like topic that we're thinking about. Okay, so how does that happen? This is the question. Does change of surface area create more or less drag? Okay, so write a little hypothesis. What do you think? Then you need to prove it. So this would be a design, like design of real life object, okay? That shows good aerodynamics, and then the same like counter design, which would show poorer aerodynamics. It doesn't have to be like total polar opposites. It could even just be like a minimal upgrade, like the lady showed in even like the car stuff. So it doesn't have to be like the kids one of like the brick compared to like the teardrop. And in the video that I'm gonna post, which you might wanna also watch before you get going on this, he talks about like drag coefficients, and it goes into like way more detail than you'd need to know, but it might still kind of get your creative juices flowing a little bit more. Okay, so then the next part is so basically just drawing like good aerodynamics, not as good aerodynamics, okay? Like a situation that's like minor enhancements to get to the good aerodynamics, okay? Then the real life application. Okay, so explain why this design would be important. Who would be keen to use your design? Like who would like to know about this? Who would be interested in this design? So a couple of ideas. You could use a car, even though that's what like all the examples that we've talked about before were. So you can, if you're like stuck, but try to think of something a little bit more creative that wasn't an example shown in class. So what else in real life would need to have an aerodynamic design for efficiency? So think about fluids, both in terms of air, and also think of fluid in terms of water, because there might be some like things out there that have to have an aerodynamic design for their ability to cut through water as well. Yeah, so think about it. I'm interested to see what you guys would be able to come up with. And you only need to draw it. If we were in class and we had so much time, we'd be like actually making models of this. And one year I even tried to get a field trip for people to go to like that tech lab in Alzana, and they have actually a wind tunnel there. Ooh, one more thing I'm gonna put in here. Testing done with, okay, and then I want you to say what you would use for the actual testing, okay? So hypothetically, I'll say testing method. Okay, so testing method. Are you, for example, going to use a wind tunnel? Would you use a wind tunnel? Or would you use maybe kind of like, let me see here. Would you just like, if you're doing like a car, would you just like send the car down a ramp to test the aerodynamics of it? Would you do like an actual like race where you have like one design and then it's like, okay, 10 seconds, how far does it get? And then here's another design, 10 seconds, how far does it get? Or would it be like, if you're going down a ramp, it's the same length of ramp, but then like the time that it took to finish off like the course kind of thing. Or like the example we saw from the little kid that was speaking, I don't know, like German or something. His design was like, I think it was being pulled. They were being pulled by these like different weights, and then which one could cut through the air the fastest. So yeah, what would your testing method be for this design that you're coming up with? And then who would care about it? Why would this design be important? Okay, so have fun with this. And these are due tomorrow. This is our last little bit of aerodynamics and air. And then we're going to be getting into flight, like much further tomorrow. Yeah, okay, so this is due tomorrow by 1 o'clock, okay? Your design. Let me know if you have questions when we get to our social studies Zoom.